So I'm going to talk about digital twins, and what I've done is basically I've contextualized it in a very specific area of value chain management, which is the supply chain process, right? Uh, me- I mean, before joining pharma, I think I was thinking the value chain management is a continuous process, but I think in Janssen and many, particularly in Johnson Johnson, right? So we see value chain management as a different process, not just to to manage the supply chain operations through the plan, deliver, and so make and source functions, but also taking an end-to-end view from the product perspective. So the value chain management as a process is a very product focused process, which decides and works on if you look at the kind of activities a value chain management leader does is on strategical and tactical level. It's all about how do you set up the supply chain, how do you decide when your product moves from an introduction phase to a launch, to a growth phase, to a maturity phase, and then to a decline phase. And then when your product moves through these stages in its life cycle, there are different trade-offs on cost, cash, and service that evaluation leaders helps the functions make, and that's very important. Why I give this introduction is because it sets the context for digital twin. Because now that I've shared that this is a very end-to-end, kind of a function, it's very important for a value chain leader to have, first of all, visibility of where the product is and how the product is behaving, whether the available to promise as a metrics, whether we'll be able to meet or not. Are we tracking right on time? Are we tracking right on cost? Are we tracking right on inventories? So this is very important on a day-to-day tactical operation level. Also, value chain leader is responsible for triggering the right kind of actions when risk or any kind of event occurs in the supply chain. So he coordinates with different functions and make sure that the impact is minimal and the business is resuming to the normalcy very soon. Right.
Saurabh, forgive me for interrupting. I just wonder if it's possible for you to just use a full screen mode for that presentation. At the minute, we're still seeing sort of like a miniature version of the main slide plus the next slide. So if we could just see the full screen version of the presentation, if that's possible.
Yes, I need to stop share and then probably share a different screen. I think I shared the wrong screen then.
It's okay.
Let me do that. Yeah. And thanks for interrupting.
No problem. That's all right.
I hope you can still see my screen. And
there you go. That's better. Okay. That's brilliant. Okay. Thank you. Carry on.
Thank you. Thank you very much. Okay. I was talking about the digital twin and the contextualization in the value chain management process. And I said that end-to-end visibility is important for the very reason that I specified. But it's also about let's say, when an event occurs, value chain leaders need to understand its impact on up and downstream supply chain, and it just not understand and learn about it, but also reason it, because then he can take the right trade-off decision. And for that very purpose, the other requirement for a value chain manager or a person who's managing this process is to take actions and monitor those actions as you go along. It's not just about one-time activity; it's a continuous activity as we go along. So that's where I think digital twin comes in and very handy. And I think it stands at a stage today that can completely transform the way the value chain management process works. If you look at the digital twin, and I'll just set the context for digital twin as well, right? So how Gartner defines a digital twin is that it's a digital representation of a physical entity. I think it's a very good simplified application, but I think it could further be extended for a practitioner, where I would say that digital twin is nothing, but it's also a way to simulate an entity's behavior, and also being able to predict the supply chain of dynamics around that entity in a given situation, and which is very important from not just from understanding learning perspective, but also from the reasoning perspective. And that I think is a real definition for a practitioner, because ultimately what you want to do is with the digital twin is you want to see analyze your current and past performances, but not just that. Looking at that, the digital twin helps in assessing and simulating different scenarios in a virtual world, so that when you are so that you don't have to really do a painful POCs and really burn your hands before I mean upfront. You can do it in virtual environment and still be able to see the impact of them. Now, if I talk about, and I can talk about pharma and consumer goods sector, right? Because I've worked in these two sectors the most. I think we are lagging in this space and in the area of digital twins. And one of the reason I say that is because not from the capability point of view. I think Industry 4.0, the simulation environment and the tools, they all were available for us to use. And it's more from the data perspective, right? So we have many physical and virtual and digital data, let's say, stages in the supply chain network, where the data is generated either, let's say, in a passive way or in an active way. When I say passive, I mean, think about a good moving from one place A to place B. Somebody is still required to go inside the system and punch it as a GR, a goods receipt activity, which to me is a passive way of capturing the data. But now we see in the last, let's say, 3 to 4, 5 years that with the let's say infusion of sensors and RFIDs and QRs and IoTs, and also on the technology side, the cloud computing and big data, what has happened is it has completely revolutionized the way the data is generated. Now the data is coming in the form of digital threads, and not just that it is coming and getting stored, but it is coming in real time, which is the key over here. Now you have more number of data sources which are available at the disposal of a person who wants to analyze and work with them. I think that's the key over here, and that's why it's becoming even more and more relevant. There are different kinds of data that we are interested in, right? So one is the system, an entity specific data. An entity could be an equipment or a facility or a network. And we were talking about the data related to their system parameters, or transportation related data, or the business specific data, or the performance and metric specific data. Now, this data combines with the capability of simulations, I think have revolutionized the way we operate in supply chain. And what I'm going to do is now in quickly next 5 to 10 minutes, I'll talk about a couple of use cases, right? The first use case, the use cases that you see over here, I mean, I placed them deliberately on side by side because I think they were existing before and they are still existing today, but the applications were very siloed. They were serving mostly the manufacturing floors, manufacturing operations. But now, because from the perspective of a value chain manager, what we can do is the use cases on anomaly detection or predictive maintenance could be used to see the impact on across different functions. And then a value chain leader is able to coordinate with the right functions to take decisions. Now, just for example, the first use case on anomaly detection, what you do is basically on a workstation, you take the parameters, right? And you take different kind of parameters on which you can measure the performance of that workstation. And then you try to monitor those parameters and see what is the normal performance and how the performance blips, or probably if it deviates from a normal standard deviation, plus minus X, few standard deviations. And that's a trigger for you to take some action. And in that action, you can either probably correct it, or you can even take some preventive actions, because now, as I said, it's an entity, it's a simulation of an entity, and you can simulate not just that particular behavior at that entity, but also 2 steps ahead or 2 steps before what would have triggered that behavior of that entity, or what impact it will have 2 steps ahead or probably forward from that entity. You can start to analyze that, and that way you can take some preventive actions. I'll just take an example of one of the case in our company, Remicade. It's a drug. It's a drug to treat autoimmune diseases, many types of arthritis or spondylitis diseases. What we do is basically we have a component in our factory which is called bioreactor, where we grow cells, and we monitor the parameters for the bioreactor, like temperature, humidity. There's another parameter called capacitance, which is nothing but the cell density, and then feed rates. Now, what we did was we leveraged a simulation tool to study all the batches that we have produced for that product, and identified the parameters and for not just entity for that particular bioreactor, but also all the raw material that are going into that entity, and mapped it to a golden batch. And for us, the golden batch is the batch which meets which is the closest to the regulatory requirements for us, right? So that's our golden batch that will pass in any which ways without where we are most sure that that batch will pass the regulatory tests. Now, what we started doing was we created this golden batch as a reference, as a benchmark, and we started comparing with the new batches. And in one scenario, I know that we started to see a blip in the feed rate of a feeder of a particular, let's say, raw material. It was, I think, media. And then we were able to immediately stop that batch. And later on, we discovered that if we would have continued that batch, it would have cost us millions of dollars. So that was a direct use case of digital twin and simulation. But not just that, if I think about, let's say, extending that use case, now think of a severe situation where the situation is not caught on the right time, and now it's a trigger of a risk or a BCP situation. Because we are able to now simulate the impact of this event across the entire supply chain network, because the entire network itself is available as a digital twin. We know that at what point in time we need to trigger a backup site, or how we want to work with the customer orders, whether we want to inform them or not. We can plan it much better than and proactively rather than reactively. I think that's the key over here. In the past, most of the applications were siloed, but now with the help of this end-to-end value chain management process and a digital replica of the entire supply chain network, we can gauge, assess the impact of a small event on a small machine across the network. I think that's the point I want to land over here. Now, following that, I think I wanted to talk about some different kind of use cases which I've started to see, in our space, specifically in value chain management space. As I said, that we work on supply chain design and supply chain network setup. Now, I think one of the use cases which I clearly see is where we can use different attributes of different entities which are operating in a supply chain network, be it your machines, equipment, be it your lab tests, be it your transportation, vehicles, or your vendors, or everything. We can create a simulated model of that network, and what it gives us is, so when we are setting up a supply chain design, either on a launch or when we are moving a product from a growth to a value optimizer or a decline stage, we can try to assess different combination of suppliers and the labs that we have, which will help us, which will have an impact on directly on those three trade-offs, which is cost, cash, and service. And depending upon the stage we are at, because I think in the launch stage, speed is the most important thing and cost is not the most important thing. And when you are in the late stage, the cost is the most important thing. So you can simulate those scenarios and work and make decisions like sourcing optimizations, make versus buy. I think it's an excellent application of a digital twin. On the other hand, I have a use case where we actually working on lead time optimization. It's a very I would say interesting example. So we have a product called CAR-T. It's a product. It's a product to treat cancer. And the interesting fact about this product is that the patient itself acts as a raw material supplier to this product. So what happens is we have to take the blood from the hospital for a given patient, and we have to take that blood and extract the T cells, which are the part of the immune system, and then we have to infuse a virus into those T cells, which end up resulting into creation of proteins, which then proteins are the cure for that particular disease, right? So we then take that T cells and protein, and eventually the virus dies off. So we take that and then we send it back to the hospital, and then that particular customized product, or let's say that vaccine or that medicine, is then injected back into the customer and the patient, and then that's how that's how it works. Now, setting up this context, how it is related to the digital twin, it's very important. For us to optimize the lead time of this entire process when we are processing the blood of a patient. Now, the processing time has got huge variability in it, right? because blood, it totally depends on the patient's biometric, right? So what kind of blood type he has, what kind of ethnicity he has, or what kind of age and health condition he is in. So depending upon that, the whole process of extraction and creation of the right proteins takes different time. So what we did was we created a discrete simulation model to create a scheduling process that will sequence the blood samples in the absolutely right manner so that we can reduce the lead time of the operation and we can take on more orders than what we were able to build. And we tested this approach, and I think it yielded a significant efficiency gains for us. And this was also one of the use case that that I thought that I should be sharing at this point in time. But I hope I was able to contextualize the value chain management as a process and the application of digital twin on value chain aspects. And I hope it is clear. I'll just give the floor back to the moderator. I mean, for taking up.